Hey everybody, welcome back to the STEM Tutor. Today we are going to be discussing nomenclature of substituents on organic compounds. I'm going to start with a main chain of decane, and I will draw all of my substituents on here and name them to show you how to incorporate them into your shape. The first substituent we need to know are alkyl groups. Alkyl groups are just carbon and hydrogen groups. For example, I can have 2 carbons coming out of my number 2 carbon here. On the number 2 carbon, we have the prefix F because we have a 2-carbon substituent, which is an alkyl group, coming out of it, and we put YL at the end of substituents to signify that they are not the main chain. 2-ethyl is the name of this substituent and the number that it's on. And the name of our main chain is decane because it has 10 carbons, and the prefix for 10 is dec. If you're wondering how I knew that this was decane, I will leave a link in the description below to the related blog post where I talk about prefixes, such as dec is the prefix for 10, and naming alkanes, alkenes, and alkynes, because this is an alkane, so I put the ending ane. Check out that blog post if you're not sure how to name the main chain, because in this video I will just be talking about the substituents. So this is a 2-carbon substituent, and it's an F with a YL on the end because we always put YL at the end of our substituents. And it's on the carbon too, so it's a 2-ethyl decane. Next, we will look at cyclic compounds. The first cyclic compound we can have is a triangle, and this is a cycloprop for the prefix. Prop because it's a ring of 3 carbons. Then we have a ring of 4 carbons, which is called cyclobute. And we can keep increasing the number of carbons in our ring, so after this, it would be cyclopentane, cyclohexane, and so on. So for example, if we had a cyclic compound as a substituent, this is a 6-carbon ring and this is 5 carbons. So this is a cyclohex, and the prefix for this one is a cyclopent. So remember that we need to include the number that each substituent is on. We have to put a YL at the ending, and we have to name them in alphabetical order. In this case, we are going to look at the P of the cyclopentane and the H of the cyclohexane in order to distinguish which one will go first alphabetically. This one would be the cyclohexane, and it's on the 6. Putting this all together, we have a cyclopent prefix on the 3, and naming it as a substituent becomes cyclopentyl. On the carbon 6, we have a cyclohex substituent, and naming it becomes cyclohexyl. Putting them in alphabetical order using P for this substituent and H for this one gives us 6 cyclohexyl, 3 cyclopentyl, decane, because decane is the name of our main chain, which is in black. If we had any other substituents coming off of the ring like this, then it would get more complicated. However, these naming rules are just for simple carbon-hydrogen cyclic compounds. Now let's take a look at benzene as a substituent. Benzene can be drawn in 3 different ways. It looks like a cyclohexane ring, but it has 3 double bonds or a circle inside because these double bonds are resonating within the ring so fast that we can draw it as a circle. So if you see these compared to this, these are different forms of writing benzene, and this was the simple cyclohexane from our cyclic compounds earlier. If we have a benzene substituent on our shape, and note that you can draw it any one of these 2 ways and it means the same thing, we would name it as a phenol. So on the carbon 6, we have a phenol group. Phen is the prefix for benzene substituents, and YL always goes at the end of our substituent, like I mentioned earlier. Then the name of our main chain is decane, so 6-phenyl decane. Now say we have an alcohol group in our shape. Alcohol substituents are called hydroxy, and because it's on carbon 6, we would have 6-hydroxy decane. Note that this is not actually how we would name this compound. Because this is an alcohol group on an alkane that has no other functional families on it, this compound is not in the alkane family anymore. It is now in the alcohol family, and it would actually be named 6-decanol. But because we haven't yet talked about naming alcohol families, I'm going to name it like this just to show you how we would name alcohols when they really are a substituent on the chain of a compound that falls in a different family. Now let's take a look at this sulfur and hydrogen group. When SH is a substituent, it's called Mercapto, and because it's on the number 6, we have a 6-Mercapto decane. Now say we have a fluorine, or a bromine, or a chlorine, or an iodine. When we have a halogen in our compound, such as iodine, fluorine, bromine, or chlorine, they are going to be named as iodo, fluoro, bromo, or chloro. So I'm going to try naming this shape if we have just an iodine and a bromine. Let's write down our substituents. On the carbon 2, we have an iodo, which is an iodine. And on the carbon 3, we have a bromo, which is a bromine. Now, which one would go first in our name? It's bromine, because it starts with a B, which is higher in alphabetical order. So we put it together, 3-bromo-2-iodo, and the name of our main chain is still decane. If we had chlorine or fluorine, it would be chloro or fluoro, like I mentioned earlier. Now say I have an NO2 group. This is called a nitro, and this would be 4-nitrodecane. If the NO2 group was replaced with an N3, that becomes azido, so we will have 4-azidodecane in this case. Now sometimes you might have something like this, where you have a substituent that branches off. So we could name this as an ethyl group, with this methyl coming off of it. And I will talk about naming branch substituents in a separate video. But there are simplified names that we have come up with, so we don't have to go to the trouble of trying to manually name this substituent as this methyl branch coming off the ethyl. So let's start with this one first. This is actually called an isopropyl group because it has 3 carbons. This end is not considered part of your substituent, it's on the main chain. It's just these 3 carbons that are actually making up the isopropyl. So this would be called 6-isopropyl-decane. Now say we have something that looks like this. We have 1, 2, 3, 4 carbons, but if we were to name this as a branched substituent, this would be named as a 3-carbon propane with a methyl group coming off of the carbon 1 on the propane. So instead of naming it like this, there's a quicker name. This is called a Sec-butyl group. This would be a 6-Sec-butyl-decane. There are other forms of substituents that can have 4 carbons. For example, this one has 1, 2, 3, 4 carbons, but connected in a different way than the Sec-butyl was. This is called a Tert-butyl. So we have 6-Tert-butyl-decane. This part is the Tert-butyl. We can also have an Isobutyl, where it's similar to the isopropyl but with 1 extra carbon. So we have carbon 1, 2, 3, and 4, and this is our isobutyl chain. So we have 6-isobutyl-decane. Now moving on to 5 carbons, we can have different forms of pentane as well. So we can have something like this, where we have 1, 2, 3, 4, 5 carbons, similar to a Tert-butyl. But because it's 5, we have the prefix pent. This prefix is a neopent, and we put YL because it's a substituent. So we have a neopentyl on the carbon 6. Now we can also have an isopentyl, similar to the isopropyl and isobutyl, but now we have 5 carbons, 1, 2, 3, 4, 5. So this is an isopentyl. Our last group is a propargyl group. This is a triple bond that has 1 carbon coming off of it. Now when we use this propargyl group in a compound, for example, if I have an extra chlorine coming out of it, this would be the group. We would name this propargyl chloride. So that's all for today. I hope this video gave you an overview of how to name different substituents. I will leave a link in the description below to the related blog post. And if this video helped you, please give it a thumbs up.